Hello, my name is Alexandra Lopez, and I'm a fourth year biomedical engineering student at the University of California, Davis, and I am the author of this code. In this code is being used to measure the shortening percentages of heart cells, and in this video, I will quickly demonstrate how. And alright, so let's start off. I already have these images pulled off here. So quickly, we're gonna get these plots, and then we'll continue. Alright, so then we just do these normal plots as you already know. You're going to want to save these values. So for this part here, we're going to label it the relaxation or REL. You'll see why in a minute. Hit save, hit replace. Next, we're going to do this one here for the contraction phase. And there we go. Maybe make that a little smooth there. Alright. Save this one here. CONT. Once again, you'll see why in a minute. Go ahead and save that. Replace. Alright, we're going to go back to this. And this is important for every code. And the reason we save them as REL and CONT is because the inputs of these custom made functions is CONT and REL. So if you name them anything else, it's not going to work. You're going to have to follow these input names here. So first off, we're going to want to refresh after every run we do. So you're going to want to exit that folder and come back to it. All right. Let's see here. Go back. All right. Just double click on the file with your left click twice on it. You're going to want to import the selection, or you could just drag the file to the right there and also import selection. Alright, so now we've got both of our CONT and REL files, and this is just a table that's going to be converted here to columns. Then those columns would be converted to those positions on the graphs. Alright, so now let's walk down the rest of the code. So this code is going to show you two things. It's going to show you the location, it's going to show you the plots. The plots of this graph is going to show you the normal plot, and it's going to show you the one that goes through the filter. Here we're using an Gole filter, and here's the plot, and this is the frames it's going to take up. For my analysis, I believe that 9 is probably the best, and will give you the closest results without altering the plot too much. Here at the min peak distance, or let's go ahead and run this. So here at the bottom, you're gonna want to type that top line. Let's see here, find it. All right, let's just go ahead and type it ourselves. Alright, so location R, locations C. Alright, now it's case sensitive, so make sure everything inputted is exactly the same as the top. And by the top, I mean this section here. Location speak, alright, CONT, REL, and then hit enter. Alright. So then you're going to get two graphs. The first one is going to be the relaxation phase, and second is going to be the contraction phase. Alright, if we go back to these graphs here, you can clearly see that these graphs match, and that the same number of parabolas in each graph is present. And alright, so let's go back to here. So the mean peak distance is simply how far these peaks have to be for it to count. So this code will filter out any peaks that are accidentally taken at this point here or anywhere in between. That doesn't make much sense. The min peak height is just stating what level of intensity these has to be achieved for the graph to be read. So this is at 500, so for sure all of these peaks are going to be taken. But if anything is below 50, it will not be indexed by this little marker there. All right, so on to the shortening percentage here. All right, so the shortening percentage is this is the final code that you need to calculate the shortening percentage for the heart cells. So we go back to these graphs here, and this one here. All right, and this code is as automated as I could make it, but it's not to its full intent. So here we're just gonna figure out style. Through intuition, we know that this band here marks this part there. If you really wanted to count them down, you would see that 1, 2, 3, 5 is about the second highest peak. 6, 7 is the highest one. So 1, 2, 3, 4, 5, 6, 7. We know by intuition that this one here is this peak here. All right, so we're gonna want to start off there. First band, we're gonna just cut a short go here. So we're gonna use these bands here. All right, so indexed in the code, we're gonna want to include 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we're gonna go from here. We're gonna put 1 through 9. Now this is gonna vary for every code. You're gonna want to make sure that these parabolas here match up with these bands here, and you do so by checking if the marker is marking the correct band. So now we move on to the contraction one, and you're gonna see here that there's still a slight bit of reading there. It will probably show up here as it is there. Okay. All right. So then we're gonna want to start off here at 1, 1. So 1, 2, 3, 4, 5. 2, 3, 4, 5. 5 there. And like I said earlier, these green markers, this green plot in the back is showing you what the normal graph looks like, and the Golay filter is going to change this. So if you want the graph to be smoother, you can alter this number here. So let's go back to locating peaks. And this portion here, let's go ahead and change that to, let's say 17. Remember, it has to be odd. And we're gonna run it again. See the graph changed. Now it looks a little different, but let's go ahead and change that back. And whenever you do this, you have to do it. You have to remember you have to do it twice, because there's a part for the contraction phase and there's a part for the relaxation phase. So both of those have to be done. All right, now let's go ahead and plot the normal one again. And there you go. Okay, so now we're going to be going from, this is 1 through 9. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so 5 through 13. All right, so now we got this set out, so then you can just copy and paste this here at the bottom and go ahead and run it. And you're gonna get these results here. All right, so then this is your shortening percentages. So you see here we get 2 zeros, a negative, 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 negative. Okay, that makes sense. And then we get the mean of this. So this mean here is only capturing the values that are less than 0. So anything that is 0 or positive is not going to be calculated in the mean percentage. So this is our final mean, and because this code can't yet store this in a data set, you kind of just have to copy it. And what I do is I just put it here, and then I will label this section with a comment, say cell 1. Alright. Let me do cell 2 afterwards. Alright, so now let's move on to the next example. Take that off. Alright, and the reason I have 2 examples is because sometimes the bands go the other way. And so we want to make sure that we get the accurate results for those two. And so I made two different codes. They're basically the same, they're just small differences in between. Once again, we're gonna save this plot. Click here, save. We hit relax, REL, replace. You have to do this for every time you run the code for a new plot. Go back here, we're gonna get right here in the middle. Once again, save, CONT, replace. Alright, come back here. You want to clear your workspace, and if you want, clear the command window down below. It's up to you. Alright, so remember, click and then come back to refresh these values here. Go back to CONT, import selection. Relaxation, import selection. Alright. So the second code here is locating peaks underscore C's. This C is basically meant to represent this contraction here. So whenever the .tif file or the hard cell is contracting to the right, you're going to want to use these two files here. And basically what they're doing is, instead of counting the indexes from left to right, they're going to be counting them from right to left. So when we were using this code here, locating peaks and shortening percentage, we were calculating those percentages using the bands from 1, 2, 3, 4, 5. Locating peaks underscore C is going to do it from 1, 2, 3, 4, 5, so right to left. Alright, so once again we have CONT, REL. So, gonna run the code, make sure you include that underscore C, run it there, and it graphs a little different here, that's fine. Let's make sure that these filters are the same. You can see here, these values are changed. You can choose to change these or keep them, whatever works for you. There. Just realize that if the intensity for those peaks is not above 100, it's not going to be counted. And sometimes you may want to count those. So as you can see here, this one and this one are filtered out because of that. So that when you index it, it's going to be 1, 2, 3 instead of 1, 2, 3, 4. So just be aware of that. Alright, locating peak C. We go back to this graph here. And so as we can see from the relaxation phase, it pretty much overlaps. So we're not going to be focused there. We're going to be focusing instead onto this contraction phase to find the values you want. So we know here it's going to be filtered out. So it's 1, 2, 3. All right. So what we're going to want is we're going to want these values that are right next to each other. The code cannot jump from this one to this one. So we're going to want to start off here. So on this image here, we will be starting on the 4th band. So it's going to be a little confusing because when we do the index, it's going to be technically number 2. But on this image here, we're going to be 1, 2, 3, 4, band number 4. Alright, so I always mark these bands just to keep it simple. 1, alright, and then 4, 6, 7, 8, 9, 10, 12. Alright, 12, so 4, 5, 6, 7, 8, 9, 10, 11, 12. There. So let's see if this, okay, so then this band here, it's a little hard to see, is counted, so we're going to be starting off from 2. Be 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 to 10. Alright, so once again, you go here, locations are. Go back here. Alright, so we had said 1, 2, 3, 4. So 1, 2, 3, 4. So we got to remember that this is going to be indexed at number 2 here. So it would be 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to go 2 to 10 on this one here. It's a little strange seeing 2 to 10 and 2 to 10, but you got to understand that these portions here are being filtered out by this min peak height here. So when we run the code, we're shortening peak percentage contraction R. We're gonna get these values here at the bottom. All right, they make sense for the most part here. And so we're just gonna go here and put those in there. All right, and that concludes this tutorial here.